So yesterday we were discussing about solutions to linear equations. We'll continue from where we left. So we discussed Cramer's rule. Okay, we discussed Cramer's rule for 2 unknowns case and 3 unknowns case, but this is valid for any number of unknowns. Now, just like we discussed for 2 unknowns case, that when the solution is consistent and determinate, that is, you have a unique solution. It represents 2 straight lines that are non-parallel, which are intersecting. If there are infinitely many solutions, it means 2 straight lines are coincident. And if there are no solutions, that means there are 2 straight lines which are parallel to each other. Okay. Similarly, for 2 straight lines that are parallel to each other. Similarly, for 3 unknowns case, we talk about planes. The first case, when there is a unique solution, this is like 3 planes have a single point in common. 3 different planes intersect at a single point. Yeah. Next, if there are infinitely many solutions, it means that either the 3 planes are coincident or 3 planes have one line in common. And if they're inconsistent, that means like 3 planes together have no point in common. So they can be parallel planes, or 2 are parallel and 1 is intersecting the other 2, like that. Okay. And then next we discussed about the matrix inversion method. The coefficients of x, y, and z are written as in the matrix form like this. The coefficient matrix A, the matrix of the unknowns x, and B is the constant matrix. So there are terms for this. Coefficient matrix. A is called the coefficient matrix. B is the matrix of the constants. And X is the matrix of the unknowns. So A into X is equal to B. So you multiply with the inverse. A inverse A times X is equal to A inverse B. A inverse A is I, and I times X is X. So X is A inverse B. So this is what we discussed yesterday. So let us do a simple problem. using matrix inversion method. Okay, all are 3 by 3. I wanted to do a 2 by 2. First, I'll do a 2 by 2. I'll give you a solve the following system of linear equations. So x plus 2y equal to 3. And x minus y x minus y equal to 6. Let me see. Okay. A straightforward solution. Uh, just looking at the equations, you can say that 3 comma 0 is the solution because 3 comma 0 satisfies both the equations. So by matrix method, how do we get? We will do both by Cramer's rule and matrix inversion method. So this is solution by Cramer's rule. Delta is the determinant of the coefficients. Coefficients of x and y. 1, 2, 1, minus 1. Which is how much? Minus 1, minus 2, which is minus 3. Delta x. Delta x is replace x by the constants. And y, coefficients of y remain as it is. You get minus 3, minus 6, which is minus 9. And delta y is, in delta, you replace the coefficients of y by the constants. You get 3 minus 3, which is 0. Now, since delta is not equal to 0, we get a unique solution. We get a unique solution. What is that unique solution? X is delta x upon delta, which is minus 9 upon minus 3, which is equal to 3. And y is delta y upon delta, which is 0 upon minus 3, which is equal to 0. Therefore, x comma y equal to 3 comma 0 is the solution, which just by, of course, just by observing we could tell. All right. This is solution by Cramer's rule. This is method 1, very simple. Just for illustration, I took this very simple problem. Method 2 is solution by matrix inversion. Solution by matrix inversion method. So the given equation can be written in matrix form as 1, 2, 1, minus 1, 1, 2, 1, minus 1, oh, minus 1, x, y, 3, 3. So this is A, this is X, this is B. Now X is equal to A inverse B. We have to get this. So A is this. What is the adjoint A by det A? What is adjoint A? A inverse is 1 by determinant of A to adjoint A. If you remember, I told you for a 2 by 2 matrix, how do you write inverse? If A is A, B, C, D, A inverse is 1 by AD minus BC into DA. A becomes D, D becomes A, and B and C become minus B minus C. Your adjoint is D minus B minus C A. So the diagonal elements interchange among themselves, the main principal diagonal elements, and the other diagonal, they are replaced by minus sign. This is only for 2 by 2 matrix. Okay, and what is AD minus BC is the determinant. If you take the determinant, AD minus BC. So we get 1 by AD 1 into minus 1 minus BC 2 times DA minus B minus C. So upon simplification, this is minus 1 by 3. Take the minus sign inside. You get 1, 2, 1, minus 1. This is A inverse. So X is A inverse B. 1 by 3 times 1, 2, 1, minus 1 times 3, 3, B. So you get 1 by 3 times. Now you multiply 1 into 3 plus 2 into 3. That is 9. Okay. 3 plus 6, 9. Then 1 into 3 minus 1 into 3, 0. So you get 3, 0. So if you remember, x was nothing but this variable matrix or the matrix of the unknowns, and you get this. You solved uh, for x and y. You see, directly you get x equal to 3, y equal to 0. So this is the method by matrix inversion. Previous one was Cramer's rule. Okay. Now let us do this. This problem was very simple. Now let us do problem by matrix inversion and Cramer's rule, a 3 by 3 matrix. All right. Let's see an exercise problem. One, two, three, fifth. Okay. Look at this question. Solve the system of simultaneous equations or system of linear equations using Cramer's rule and matrix inversion method. So the equations are 2x minus y plus 3z equal to 9, x plus y plus z equal to 6, x minus y plus z equal to 2. Okay. So first part, solution by Cramer's rule. Solution by Cramer's rule. So delta is determinant. Tell me coefficients of x, y, and z. All right, I want you to solve and find the value for this. 2 minus 1, 3, 1, 1, 1, 1 minus 1, 1. Tell me the value of the determinant.
Sir, I'm not sure, but for the keys 1, 2, 3.
Answer is 1, 2, 3. That is for sure. But I'm asking about the determinant. I'm talking more about the procedure, not the final answer.
Sir, I got it as -2 determinant.
-2, right? You're right. Expand about the first row. 2 times 1 minus of -1, then minus of -1 times 1 minus 1 plus 3 times -1 minus 1. So you get 2 into 2, 4, minus 0, minus 6, which is -2. Now what is delta x? Delta x. Replace coefficients of x by constants 9, 6, 2 and keep the other coefficients uh, as they are. Now let us expand. So first 9 into 1 minus of -1, 1 plus 1, then minus of -1 times 6 minus 2 plus 3 times -6 minus 2. So 9 2's 18 plus 4, this is -24. So we get -2. All right, delta x is again -2. What is delta y? Replace in delta, replace the coefficients of y by the constants. So you have 2, 1, 1, 9, 6, 2, 3, 1, 1. Now we have to expand this determinant. We evaluate this determinant twice, 2 times 6 minus 2 minus 9 times 1 minus 1, 1 minus 1 plus 3 times 2 minus 6. Okay, so this is 2 into 4, 8 minus 0 minus 4 into -4 times 3 minus 12. So you get -4. Delta z, replace, see the coefficients of x are 2, 1, 1, coefficients of y are -1, 1, -1, and coefficients of z should be replaced by the constant 9, 6, 2. Okay, we have replaced 3, 1, 1 by 9, 6, 2. 3, 1, 1 has been replaced by 9, 6, 2. Rest are all same. Now expand. 2 times 2 minus of minus 6 plus 6. Then minus of minus 1 becomes plus 1 times 2 minus 6 plus 9 times plus 9 times minus 1 minus 1. So 8 twos 16 minus 4 minus 9 twos 18. So you get minus 6 as the answer. All right. Therefore, x is delta x by delta minus 2 upon minus 2, which is 1. Y is delta y upon delta, which is minus 4 upon minus 2, which is 2. Z delta z upon delta minus 6 upon minus 2, which is 3. Okay. So x, y, z. The solution is 1, 2, 3. So this is the Cramer's rule for solving the matrix simultaneous linear equation. Next, the matrix inversion method. Solution by the matrix inversion method. So the equations again we'll rewrite. The equations 2x minus y plus 3z equal to 9. X plus y plus z equal to 6, and x minus y plus z equal to 2. All right. So the equations in the matrix form. The equations in the matrix form can be written as two minus 1 3 1 1 1 1 minus 1 1 times x y z 962. So this is the coefficient matrix A. This is the variable matrix X, and this is the constant matrix B. So X is equal to A inverse B. So we need to find A inverse. So A is this. 2 minus 1 3, 1 1 1, 1 minus 1 1. Now what is the, we have to find the adjoint of A. So for that we'll find the minus first. What is minor of an element? Remove the row and the column containing the element, take the submatrix and find its determinant. That will be the minor. So for 2, this is 1 minus of minus 1, 1 minus of minus 1, 2. For this one, for minus 1, the first row, second column, remove the first row, remove the second column. Then you have 1 into 1 minus 1 into 1, 0. Then third, this 1 comma 3, or first row, third column. Remove the first row, the third column. Then you have 1 into minus 1 minus 1 into 1, minus 2. Okay. Next, for the second row, first column, remove the second row and the first column. Then you're left with minus 1 3 minus 1 1. So minus 1 into 1 is minus 1, minus of minus 1 into 3. So plus 3, minus 1 plus 3 is 2. Then this middle element, remove the second row, second column. Then you have 2 into 1, 2, minus 1 into 3. So 2 minus 3 is minus 1. Then this one, second row, third column, minus 2 plus 1, minus 1. Next, the last row. Last row is for this minor will be this determinant, minus 1 minus 3, which is minus 4. The second term here, remove this row, this column. You have 2 minus 3, which is minus 1. And last one, 2 plus 1 is 3. This is the minor. What will be the cofactors? Cofactor. Cofactor is, the first, third, alternative plus, minus, plus, minus, plus, minus, plus, minus, plus. So alternative. So 2 and minus 2 will be multiplied with plus sign. So it remains same. Middle term with the minus sign. But because multiplied by 0, it is 0. Then this gets multiplied by minus 1. Middle term with plus 1. The last term with minus 1. Then this is plus, this is minus of minus 1 plus 3. This is cofactor. What is adjoint A? It is transpose of the cofactor matrix. 2 0 minus 2, 2 0 minus 2, then minus 2 minus 1 1, minus 4 1 3. This is adjoint. Now what is determinant? Determinant of A, elements of the matrix along a row multiplied by the cofactors of that row you can take. So 2 into 2 minus 1 into 0 plus 3 into minus 2. So determinant is minus 2. 4 minus 6 is minus 2. So A inverse is adjoint A by determinant of A. So minus 1 by 2, because 1 by minus 2 it is, times the adjoint. Now B is 962. So X is A inverse B. So half of 2 minus 2, 4, 0 minus 1, 1, and minus 2, 1, 3 multiplied by 962. So let us do now. So this is 3 by 3 into 3 by 1. You will get 3 by 1. 3 rows, 1 column. So 2 minus 2, 4 multiplied with 962. So 2 nines, 18, minus 2 6, 12, plus 4 twos, 8. Just a second. There's a minus sign. I'm sorry. 2 minus 2 minus 4. Adjoint. 2 minus 2 minus 4. 0 minus 1 1. Minus 2 1 3. One minus sign can make a lot of difference. All right. The next 0 into 9, 0. Minus 1 into 6, minus 6. Plus 1 into 2, 2. Then minus 2 into 9, minus 18. Plus 6, plus 6. So you have minus half times. This is 18 minus 20 minus 2. Minus 6 plus 2 minus 4. Minus 18 plus 12 is minus 6. So now you multiply minus half inside throughout. So minus into minus plus half into 2 1. Minus into minus plus half into 4 2. Plus half into 6 3. So you got the solution. Same solution. Oh, sorry. Equal to. Which method is better? Cramer's method or matrix inversion?
Grammars.
Cramer's method is better as long as they are small problems. All right. In Cramer's method, we need to evaluate for 3 by 3 matrix. We have to evaluate 4 determinants of 3 by 3 order. 4 determinants of 3 by 3 order. Delta, delta x, delta y, delta z. All right. Suppose it is 4 by 4. You will have to evaluate determinant of the order 4 by 4, you have to evaluate five determinants. Whereas in matrix inversion, you have to find the determinant only once. Of course, adjoint will require a lot of computation to find out by itself. So both are intensive, but relatively, as you go to higher numbers, inversion method is better. So when you do computer programming later in your degree level, so in computer programming, lot depends on how fast the computer should solve. So the number of operations has to be reduced. So both, in fact, the Cramer's rule will be intensive. Matrix inversion will be less intensive in terms of operations. However, that's also very lengthy. But there's a very beautiful method called Gauss-Jordan method, or um, Gauss-Jordan method, or Gauss elimination method, which right now it has been removed from your syllabus, and it is not there for entrance exams also. So I'll not touch that, but Gauss elimination and Gauss Jordan methods, they're very excellent methods where you avoid this whole business of finding out the determinants, and directly you get to the solution. If later some time is there towards the end, I can discuss that. So most of the computers solutions, software solutions with find inverse, they use the method of Gauss elimination and Gauss Jordan. Very, very excellent method. So this was Cramer's and matrix inversion. Now for system of simultaneous equations, there is another um, not a solution, but whether we want to check whether the solution is consistent or determinate. So there is this concept of rank of a matrix, and to solve the system of linear equations. Someone asked me that in the group you are not able to see the
Yes, sir.
PDFs. At the end of the class, I will tell you how to see.
Okay.
Okay. Now this is another concept, rank of a matrix. Very excellent concept. By this, we can just tell, seeing the just seeing the matrix and finding the rank, we can tell whether the system is consistent, inconsistent, determinate, indeterminate, and so on. All right. So first definition here is that of a submatrix. Now submatrix is a matrix obtained by deleting some of the rows or columns or both from a given matrix. A matrix obtained by deleting some of the rows or columns or both from a given matrix is called as a submatrix. It is a submatrix of the given matrix. All right, you given a matrix A, you eliminate either one row or two row, you will get a submatrix. You eliminate one column, you get a submatrix. You eliminate both columns, two columns, you get a submatrix. You eliminate one row and one column, you get another submatrix. So any matrix in which one row or one column or both or many or few rows or few columns are eliminated is a submatrix. Next, definition of rank. Rank of a matrix. Now let A be a non-zero matrix. Rank A, the rank of A is defined as the maximum of the orders of the non-singular square submatrices of A. The maximum of the orders of the non-singular square submatrices of A. Okay. This is called as a rank. We will take example of it. There's another definition of rank which says, I'll just see yesterday's file, which is defined in another way. Matrix is a big chapter actually. There's another definition which is in one sense the same, but it gives a better idea. Now, rank of a matrix. A positive integer R is said to be rank of a non-zero matrix A if there exists At least one minor in A of order R which is not 0. If there exists at least one minor in A of order R which is non-zero. And every minor of A of order greater than R is 0. Okay. So every minor, so minor is 0 means minor is a determinant of a submatrix. For determinant to exist, it has to be a square matrix. So what here the previous definition said is the rank of A is defined as the maximum of the orders of a non-singular square submatrix of A. Maximum order, the order 2 or order 3. So if a minor of order 2 is non-zero, then and all the minors of order 3 are zeros, then it is it is the rank is 2. We'll take an example. With example only it will be clear. Okay, we'll take 2 examples and we'll end the class here today with this. Rank of a zero matrix is defined to be 0. That is 1. Now let us take example 1 from the textbook example only I'm taking. This is matrix 1 2 minus 1 to 1 minus 1 0 2 0 1 minus 1. So first I take the determinant of A. Expand about the first column. Why? Because there is 1 0. It will be easier. 1 times 0 minus 2. 0 minus 2. Then minus of minus 1 is plus 1 times minus 2 minus 1 plus 0 times whatever it is, 4 minus 0. So you get minus 2 minus 3, which is minus 5, not equal to 0. So A is a non-singular matrix. A is a non-singular matrix. So the order, the greatest order, we have gone from the greatest order. What is it saying? The maximum of the orders of a non-singular square submatrix of A. First we start with the matrix itself. So A is non-singular and it is 3 by 3. So rank of A is 3. Because third order determinant is non-zero. Okay. Now let us take another example. 3 examples we'll take. A is minus 1, minus 2, minus 3, 3, 4, 5, 4, 5, 6. Okay, the difference is plus 1 here, so easily you'll get zeros, no problem. So let us take determinant of A. When you take determinant of A, minus 1 times 6 4 is 24, minus 5 5 is 25, then plus 2 times minus of minus 2.